Hi, this is Andrea Bravo and I'm a PhD student at DTU, the Technical University of Denmark, researching of presentation of information and data visualization in virtual reality, augmented reality, and tangible user interfaces. Today I will be explaining the Virtuality Continuum and its link to data visualization. So first of all, we live in a world of increasing speed, quantity of information, and quantification of processes. So how are we supposed to communicate this increasing quantity of information, and how can we take advantage of these new technologies that are emerging, such as virtual reality, augmented reality, tangible user interfaces? These are types of technologies that can be named immersive. Now let's define what immersive and immersion means. So immersion is a measurable parameter conditioned by the hardware capabilities of the virtual reality system in terms of sensory fidelity of the virtual reality experience. This definition is according to Slater. And the level of visual immersion is how close the system's visual output is to the real-world visual stimuli. It's depending on many technical parameters such as field of view, field of regard, display size, display resolution, etc., etc. Let's check this out. So a higher level of immersion has much more details. For example, details that we can find in our reality, while a lower level of immersion has much less details presented in the scene. Now let's check these immersive technologies in the Virtuality Continuum. So the Virtuality Continuum is a taxonomy that merges the real world and the virtual one. It's the first taxonomy that classifies technologies according to this criteria, and this was coined in 1994, so almost by this time, 27 years ago. In between the real world and the virtual world, there are all the types of technologies that can be named for mixed reality. So let's explore these technologies. We have first tangible user interfaces, which is based on physical embodiment of digital information. These are devices that you can touch and that convey the properties of data. On the other extreme, you find virtual reality, which is totally surrounding yourself with a virtual stimuli, meaning it's a totally computer-generated world where there is nothing of the real world experience. Then you have augmented reality, which blends the computer-generated stimuli with the real one. And we have augmented virtuality also. Augmented virtuality is the opposite of augmented reality, which means real-world data augments the virtual world. Let's check a few examples of this. Just to refresh the memory, we have here Inform, which is a tangible user interface that can render 3D content physical. It was developed in 2013 in order for users to interact with digital information in a tangible way. It's a dynamic shape display and can be used to render information such as bar charts or create tangible examples of math formulas. We have, for example, this is a clear example of augmented reality called Virtual Shark, and it introduces a computer-generated shark in your room. This is done via Microsoft HoloLens technology. Then you have here an example of augmented virtuality in which you introduce the real-world data, gestures in that case, into a computer-generated world to play with the game. And finally, we have virtual reality, in that case, afforded by the standalone device Oculus Quest and 2 controllers. So as you can see, the man is playing a boxing game, and the gestures he does are mimicked by the avatar he embodies in the game. So I explained what is immersion, virtual reality technologies. Now, why immersive? So, first of all, immersive technologies give this sense of immersion in the environment, immersion referred to as the objective level of sensory fidelity a virtual reality system provides. So this level of immersion creates a sense of presence, which refers to the user's subjective, psychological response to a virtual reality system. Then virtual reality enables embodied interaction, thus integrating different parts of the body in the virtual reality experience and expanding the relationship between the user and the system. Paul Dorish states that embodied interaction turns action into meaning, making a clear reference to embodied cognition and the importance of the bodily processes to make a sense of the world. Finally, we have also multisensory input and output devices depending on the hardware we have. So usually they can convey vision and sound, plus sometimes you have haptics, smell, and even taste. Now let's check what these embodied experience mean. For example, by sketching. Sketching, we can convey volume by conventions in shading usually. So more shade means there's more depth usually. However, with VR, this changes totally, because you have this embodied experience of a drawing in which it's a merge between what is a sketching activity and a sculpting one, right? And it also fosters action, meaning it fosters embodied interaction with the whole body. Here you have this experience with Google Tilt Brush. Now that we explored immersive technologies, let's go towards the bridge, towards data visualization, to help explain the complexity of information that we're living in today. First, why data visualizations? So, as a first step, it enables more natural interactions. I talked about embodied interaction and interaction with the body. But this is also a much more natural way for us to interact, because that's how we do it in the real world. So certain types of hardware give the possibility to have more natural interactions with datasets. Also, certain studies have proven that there is more engagement with the content presented, in that case datasets, in decisions addressed in the session. And also there's more engagement with the people you're sharing the experience with. So engagement at both levels from the content and the people you're talking with, according to these studies that I'm showcasing here. Finally, it's also beneficial for depth-related tasks and, of course, spatial understanding. With spatial understanding, we understand about the cognitive processes that can make sense out of the geometry of space you are surrounded by, or the geometry of an object you're just visualizing, for example. Now, let's check again the Virtuality Continuum and data visualization between incorporating now some data visualizations. So we have, as I said, tangible user interfaces. Now let's check an example of data visualization. So this example of tangible user interface provides real-time variable haptic feedback in response to the way users press the pins. It displays seismic multi-layered data, with each layer having a unique material properties. So traditionally, this type of data is viewed by geoscientists as layers of section-cut visualized data. However, when they need to present this information to policymakers or businesses in the oil and gas industry, you need new tools to facilitate the understanding of data in an intuitive way. This is one of the cases where you can use this type of hardware. Now, we have then augmented reality and augmented virtuality. Let's present a hybrid example, for example, by the Japanese company Mall. So this system has been tested in some of its ships, and as you can see, real-time data stemming from the ship's radar at the same view. The information is overlaid to the text view. So this supports decision making during the navigation made, for example, in heavily trafficked waters. And then we have virtual reality. In virtual reality, I will show you an example of a business intelligence tool for data exploration and analysis. So this is the case of an integration of virtual reality into Power BI by 3Data. You can decide to present a multidimensional data set in 3 dimensions to get a better understanding of it. However, this is mostly used by experts. So, as a conclusion, this is not about technology push, but about how immersive visualizations can address the issue of complexity in a more human way. In a more human way through immersive presentations that can create fact-based storytelling, accessible, engaging, and memorable. Now, thank you. Please give a hands up to this video. It's the first time I'm doing such an experiment, and depending on the response, I will see if there is need for more or there is simply the demand for it. Thank you.